Okay, now we want to use the fundamental theorem with the substitution method that we learned in Lecture 5. So in Lecture 5, you learned how to use integration by substitution to evaluate indefinite integrals. And the substitution method is really just an advanced way of finding an antiderivative. So we can use the substitution method on definite integrals as well if it is necessary to find an antiderivative. So remember, when you're using the substitution method, you're looking for two things: a function that is inside of another function whose derivative is somewhere in the problem up to a constant. Okay, so example 2, we want to evaluate the definite integral from 0 to 1 of x times x squared plus 3 squared. Okay, well, the reason I know that this is a u substitution is because I see a function inside of another function. And so I'm going to choose that as my u, and so u is going to equal to x squared plus 3. That means that my du is going to be 2x dx, and I see x dx in the problem. So I'm going to divide by 2 in order to get the x dx by itself. Okay, so if I start putting back together this integral, I'm going to have 1/2 and then du at the end. Integral sign is going to stay an integral sign, and then I'm going to have u to the second power. And then the last thing, and this is different from Lecture 5, so this is the new thing that we're introducing here in Lecture 7, is that I have to find some way to replace those bounds right there. Those bounds are in terms of the variable x. We have now shifted everything to be in terms of the variable u. So what I have to do now is I have to replace that 0 and that 1 with new bounds. And so what I'm going to do is I'm going to plug in that 0, which is the original lower bound, into my equation for u, which is back up here in yellow, and I'm going to figure out what the new bound is. So that's going to be 0 squared plus 3, which is equal to 3, and so that's going to be my new lower bound. And then my new upper bound is going to be u of 1, which is going to be 1 squared plus 3, which is equal to 4. Okay. Now that I am here, I'm going to do this in a different color. Now that I am here, this is the problem that I am now trying to solve. This problem is now completely irrelevant. So everything to do with x just kind of goes away, and now I am trying to solve this problem, 1/2 the integral from 3 to 4 of u squared du. Okay, so if I do that, I need to first of all find an antiderivative. So I'm going to write the 1/2 that came from right here, that just gets copied down, and then the antiderivative of u squared is 1/3 u cubed, evaluated from 3 to 4. Okay, well, this is going to be 1/6, and then if I plug in 4 first, 4 cubed is going to be 64, minus 3 cubed, which is 27, and so for my final answer, I'm going to have 64 minus 27, which is 37, and then divided by 6. Okay, so there is my final answer. Now, be careful. I want to say this again just to be clear. Once you shift everything to u, you are completely done with x. So these things right here, okay, this original problem, completely irrelevant once you substitute everything into the variable u. Okay, letter B, we have the integral from 0 to 4 of x over the square root of x squared plus 9. So again, I know it's a u substitution problem because I see a function, x squared plus 9, inside of another function, which is the square root. Okay, so u is going to equal to x squared plus 9. That means that du is equal to 2x dx. And again, I see x dx in the problem right here, so I'm going to solve for that, so that it says 1/2 du is equal to x dx. Okay, so my new integral is going to be 1/2 the integral, du down here at the end, and then what's left over is a 1 over the square root of u. Well, instead of 1 over square root of u, I'm going to write it as u to the negative 1/2. Okay, if you have questions on that, then please feel free to let me know. The reason it's negative is because that square root was in the denominator, and the reason it's a 1/2 is because it was a square root. Okay, the last thing I need to do is figure out my new bounds. So u of 0, which was my original bound, is going to be 0 squared plus 9, which is 9. So my new lower bound is 9. And then u of 4 is going to be my new upper bound. 4 squared is 16, plus 9 is 25. And if you're lost as to where I'm plugging that into, I'm plugging that back in right back up here to get my new bounds. Okay, so 25 will be my new upper bound. Now I'm ready to take the antiderivative. So you have to be very careful to take the antiderivative once you get here. So this is going to be 1/2. The antiderivative of u to the negative half is 2 u to the 1/2, evaluated from 9 to 25. The 1/2 and the 2 here are going to cancel, and so what I'm really going to get is 25 to the 1/2 minus 9 to the 1/2. And since to the 1/2 power means square root, what I really have is 5 minus 3, which is equal to 2. Okay, let me know if you guys have any questions on that. On your assignment, all of the problems are going to be mixed together. So some of them will be u substitution, and then other ones will be easy, like example 1. You have to determine which method of finding the antiderivative you're supposed to use. And the hint that I want to leave you with is look for a function that is inside of another function. If you see that, then it's more than likely a u substitution problem.